So hello everyone, welcome back to my YouTube channel. So in this video I will be explaining about the noise immunity, and as I've explained in my previous video about the input and output impedance, and I've also explained about the bandwidth. So if you have not watched that video, please go and watch, so you will be in the continuity of the series. So without wasting any time, let's get started. So now we'll see about the noise immunity. So before saying the noise immunity, we have to learn about noise, what exactly the noise is. So noise is any unwanted signal which is present in our input. So this noise can be from the various factors like the electromagnetic interference from the neighboring cable in which the input is transferred. There might be some neighboring cable which might interfere with my inputs. It might be the environmental factors such as temperature and pressure. So we have to eliminate this. So as we know that our Opamp is a differential amplifier, so this will only amplify the differential signal. So let this be plus minus, so here it will be minus plus, and so these two inputs will be amplified. Okay, so the only useful term, the only useful component here is the differential terms. So but here there might be some common mode voltages also. There might be some common mode voltage whose polarity is same, as it is common to both of the input. Their polarities might be same. So we will call this voltage as VCM. This is common mode voltage. So actually this voltage is noise for our Opamp. So our Opamp can successfully eliminate the VCM. Why it can eliminate? Because V out is A into A plus minus A in. So this might be containing VCM and this is also containing VCM. So how we can expand this? So let this as VID. So this will be VID minus. So it will be VID plus VCM minus VID. So this is minus VID as it is a differential input. So it is minus VID plus VCM. So if we expand this VCM and this minus goes here, so this VCM get cancelled. So our output is, so this minus plus VID. So we have successfully eliminated the VCM. So from this what we get is we have to convert the noises into the common mode voltage. So you might have read everywhere that somewhere that your VCM is noise. So we'll see how to convert that noise into the VCM. So is it clear why we convert the noise into VCM? Because our amplifier will eliminate the common mode voltage. So now we will see why the noise is coming in the common mode only, why it is not coming in the differential. So for this I will copy this and I will paste it here. So this is our Opamp. So for this Opamp we need two inputs. So this might be somewhere else and I might be giving my inputs from a different location. So there will be a transmission here. Okay, so from a distance I am giving my VID and minus VID. I am giving my inputs as a differential form. So let's consider this as a sine wave, and the minus of it is in this one. Okay, so I'm transmitting it. So this will go here and this will go here. So this is our transmitting location where this cable might be interfere with other cables and a temperature factor all. So the temperature and other factors will equally contribute to these cables. So the voltage which is getting generated across this cable as a noise is same to both of this. That means the change in voltage, if it is plus del V or minus del V, it will be same. If it is getting plus del V, this will also get plus del V. If it is getting minus del V, this will also get a minus del V. So which is common to both of this. That's why the noise is always VCM. So to make this, we are transmitting it in the differential mode, so that the noise is common and our operational amplifier will eliminate the VCM. So this was the concept.